It has a measurement of more than 100,000 light-years and is home to an estimated 200 billion stars. Yet, we truly don't claim to know much about our home galaxy, the Milky Way. Well, obviously, you learn constantly, even on your own cosmic doorstep. Truth be told, in recent months, experts have gathered a series of breathtaking discoveries that shed an entirely new light on the Milky Way. This even starts with a very basic point. After all, the latest data suggests that we have been understanding the Milky Way incorrectly this entire time. But that's not all. Simultaneously, astronomers have also discovered a massive 16,000 light-year structure in our home galaxy. They have also found that the strange gravitational beast at its center has undergone events that stunningly reveal the fundamental forces of the universe. To begin, here's a little test question. Why is the Milky Way called the Milky Way? Well, the reason our galaxy has the word milk in its name is thanks to the ancient Greeks. According to an ancient legend, when we look at the brilliant night sky, we see nothing other than the spilled breast milk of the goddess Hera. A milky pattern applies not only to our own galaxy, but to all galaxies. After all, the Greek root galaxias means milk. But if we now move away from ancient mythology and instead explore the galactic facts, we recognize that the so-called milk of the gods is actually star clusters sprinkled with light and dark clouds. Anyway, since we are located within the Milky Way with our Earth, it's natural that this Milky Band, which rises in the southern sky on clear summer evenings, represents only a small portion of our galaxy. From our point of view, it's simply impossible to see the Milky Way in its entirety. Despite this, astronomers have been able to create a general picture of our galaxy. The Milky Way is classified as a barred spiral galaxy with 5 autonomous spiral arms, 2 of which we can observe in the sky. The diameter of the Milky Way is estimated at 100,000 light-years, although apart from its center, it is only 3,000 light-years thick. Meanwhile, the central thickness is about 16,000 light-years. The true heart of our galaxy appears invisible to our natural eyes due to the many dark clouds obscuring it with interstellar matter. Despite these visual barriers, it is now certain that a supermassive black hole lurks at the Milky Way's center. Sagittarius A** is an incredibly massive black hole with over 4 million solar masses. Contrary to what you might think, this is not unusual for galaxies. Experts now believe that nearly every galaxy's center is adorned by such a massive gravitational beast. As for smaller stellar black holes, which arise from collapsing stars, scientists estimate there are about 100 million of these enigmatic formations in the Milky Way. Regarding the number of stars, astronomers' estimates can vary significantly. While some suggest our galaxy has only 100 billion stars, others believe it houses up to 400 billion stars. Given data from missions like Kepler and other studies suggesting an average of 1 to 2 planets per star, there could be between 100 to 800 billion planets in the Milky Way. However, not all these planets resemble Earth, which is evident. In 2022, researchers from Nottingham estimated that as many as 36 advanced civilizations might have developed in our galaxy. These calculations, of course, come with significant uncertainty. The Milky Way, like Earth and the Solar System, is not an isolated entity, but part of much larger cosmic structures. The Milky Way belongs to the Local Group, a cluster of around 35 galaxies. Furthermore, the Local Group itself is part of the Virgo supercluster, which is a supercluster of galaxies. The Virgo supercluster is, in turn, part of the Laniakea supercluster. Or, so we thought, until recently. A new map of the gravitational catchment regions in the local universe now suggests that we've been misplacing our galactic home all this time. In fact, it does not belong to the Laniakea supercluster at all, but to the much larger Shapley supercluster. On principle, such attractors act as gravitational wells, pulling galaxies toward them over vast regions, much like the way the terrain dictates the flow of rivers. The study that placed the Local Group in the Laniakea supercluster was based on 8,000 galaxies. However, the new study, using data from the cosmic flows for survey, involved 56,000 galaxies within a radius of around 1 billion light-years. This vast amount of new data ultimately revealed that there are 17 significant gravitational wells in our cosmic vicinity. It also showed that the streams associated with the Milky Way are more strongly directed toward the Shapley supercluster. In figures, this means nearly 60% of the structures are moving toward Shapley, compared to only 40% toward Laniakea. Meanwhile, researchers have also identified enormous magnetic structures over 16,000 light-years long at the ends of the Milky Way's central bar. These structures rise far above and below the plane of the galaxy. They are believed to originate from regions of active star formation rather than the galactic center. Scientists suspect these are the results of supernova explosions, where overlapping stellar blasts release material at speeds of up to 1,000 kilometers per second. These stellar events are likely responsible for the magnetic filaments and the powerful radio structures extending beyond the galactic disk. Lastly, Sagittarius A*, the Milky Way's central black hole, has presented another cosmic mystery. Though not a quasar, a term used for active galactic nuclei emitting enormous energy, Sagittarius A* has shown past activity. Today, it rotates at an unexpected speed and is tilted relative to the galactic plane. To explain this, researchers used data from the Event Horizon Telescope, EHT, and concluded that Sagittarius A* may have collided and merged with another massive black hole in the distant past. Simulations suggest that this collision involved a partner black hole with about 25% of Sagittarius A*'s mass, originating from a dwarf galaxy. This collision significantly altered Sagittarius A*'s rotation and alignment. The event likely occurred around 10 billion years ago, coinciding with the Milky Way's merger with the dwarf galaxy Gaia Enceladus. Detailed analyses even suggest that the two black holes collided about 1 billion years after the galaxy merger, permanently influencing the Milky Way's core. The tendency of Sagittarius A** to move toward its current properties is an invigorating revelation. It provides additional evidence of the dynamic foundational events underlying the current structure of our galaxy. From a certain perspective, the merger of two supermassive black holes has not yet been directly observed. However, experts believe this will change soon. Gravitational wave detectors, such as the Laser Interferometer Space Antenna, will likely be able to detect and study the party of the giants. If you look below this video, you can see the like button and the subscribe button. Press the like and subscribe buttons now so you never miss a new video from us again. We'll see you soon.